So in this section, we're going to go through all of the formulas for surface area of all different types of solids. And you should be writing down all these formulas because we are going to do examples and you need to know what the formulas are in order to do the examples. So the first one that we're going to go over is the rectangular prism or cube. That's also considered a rectangular prism. And your formula for the surface area is 2 times length times width plus 2 times length times height plus 2 times width times height. The length and the width are usually on the base of the rectangle, so on those bases, and then the height is the length that kind of is going up into the air. And then the second solid that we're going to go through is the cylinder, and the surface area formula for the cylinder is 2 pi r squared. That first portion represents the top and the bottom bases, those circle bases that the cylinder has, and the 2 pi r, which is the radius times the height, is going to represent the curved portion that's like all around the cylinder. The next one is a pyramid. This one's probably going to take the longest to go through in all honesty. Your formula is 1/2 L, and L stands for the slant height. So that's going to be the variable that represents slant height all of the time, no matter what solid you're working with. So it's 1/2 slant height times the perimeter of the base. And remember that the base of the pyramid is across from the point that's at the top of the pyramid, plus capital B. And capital B, so whenever anything is really a capital letter, it's going to be talking about the area of something. So capital B represents the area of the base. And I'll kind of go through this one step by step when we get to the example of the pyramid. And the next one is the cone. So the surface area of a cone is pi r squared. Once again, that's the area of the circular base of the cone, plus pi r times your slant height, which is like the curved portion of the cone. So these are the main four that we talked about in the vocab screencast, but there is another type of solid we're going to go through, and that is a sphere. And a sphere is a set of all points in space equidistant from a given point called the center. So we have a center of a circle, and we also have the center of the sphere. It's kind of like the same idea, and these vocab terms are similar as well. So the radius of a sphere starts at the center and goes to the end of the sphere, kind of like the radius of the circle goes from the center of the circle to the end of the circle. Your chord, same idea. It's a segment whose endpoints are on the sphere. And the diameter is the chord that goes through the center or contains the center. So it's double the radius. And then your hemisphere is going to be half of a sphere. So we're going to kind of be working with both of those. Sorry, the picture should have came up before the hemisphere definition. So you can see what the radius looks like and what the diameter will look like in your circle or your sphere. So there would be the radius, half of it, and then your diameter is the entire thing. And then once again, hemisphere is half of a sphere. So for spheres and hemispheres, their surface area formulas. A sphere is 4 pi r squared. Once again, r is going to represent the radius. So if it gives you the diameter in the picture, you will need to take half of that to get the radius. And for your hemisphere, so a hemisphere is half of a sphere. And this is where people get a little confused, because if you were to take the formula for the sphere and divide that by 2, you would get 2 pi r squared, which most people would think is the surface area of a sphere. However, when you're working with the hemisphere, you do have half of the sphere, but then you also have a circle on top of that. And surface area is like the total area of all of the different surfaces, so all of the outside exterior things. So when you do add those together, you do get 3 pi r squared. I kind of ran out of room down there, but that would give you the surface area formula for the hemisphere. Now we're going to start to go through some of the examples, and they're all kind of mixed up, so we are going to kind of identify what shape each one is. So for the first one, this one is actually a rectangular prism. So I'm just going to write what it is down there. And then your surface area formula for this one, this was the one that was 2 times length times width. So I'm just going to start kind of writing out 2 times length times width. And I always assume that the length is the longest, but it doesn't really matter. So that's a 4. So 2 times 12 times 4 plus 2 times length times height. So that would be 2 times 12 times 3 plus 2 times width times height, which would be 2 plus 4, or I'm sorry, 2 times 4 times 3. So that would be substituting all of the values into the formula. And now I'm just going to take each separate component. So like the first 3 numbers that we're going to multiply together, I'm going to simplify all the multiplication. So to get 2 times 12 times 4, you do get 96. And then 2 times 12 times 3, we get 72. And then 2 times 4 times 3, we get 24. And then when we add all of those together, our total surface area for this rectangular prism is 192 centimeters. Or I'm sorry, not centimeters. There's no unit there. So that should be units squared. So that's the first example. And before we actually get to the second example, I do want to give you your code word. And your code word is watermelon. Once again, your code word is watermelon. So your second example, this one is a sphere. It's the total sphere. So I'll show you what the hemisphere looks like. I know I didn't have a picture of that one before. This one, your surface area was 4 pi r squared. So 4 times pi, and you can just use the pi button on the calculator, or you can use 3.14. I know because sometimes if you don't have a calculator, you may not have the pi button, like if you're using a phone or something like that. So you can use 3.14. We'll just change it by a couple decimal points. So it's 4 times pi times the radius. Now this whole thing, 18, is the entire diameter. So we need half of 18 to get the radius, which would be 9. And that is squared, so 4 pi r squared. And then when we do simplify that into the calculator, we are going to get 1017.9 meters squared. So those are the first two. We're going to do more examples as we go through. And then for the next one, this one is going to be our cylinder example. And then with this one, I'm actually going to kind of go through it the same way that I did with the other one. So break it apart where the addition sign is. So the first half of the surface area formula, excuse me, is 2 pi radius squared, and the radius is 4. And this one, it does give us the radius, so we don't have to take half of the diameter or anything like that. And then the second half after the plus sign is 2 pi r times the height. So 2 pi times the radius times the height, which is 10. And now I'm going to kind of do the addition on the first part of multiplication, the second half break it apart like it did before. So 2 pi times 4 squared will give us 100.5. And then 2 pi times radius times height will give us 251.3. Lastly, we add them together to get 351.8 inches square. And the next one, this one is a pyramid. And whenever we're working with pyramids, we do want to name the pyramid based on the shape of the base. So you might have different shapes for the base. So this one, we know that the sides are both 12. So this is going to be a square pyramid. And pyramids are really the only one where you're going to have to add that extra name into it to name it by the base, which would make it square pyramid. This one, I'm going to write the formula for the surface area because we're going to kind of do this one in little pieces. So it's 1/2 slant height times perimeter plus the area of the base. So the first part that I'm going to kind of take care of is I want to find the area of the base because it's really easy if you find each piece separately instead of trying to do the whole thing in one shot. A lot of people mess it up when they put it into the calculator. So I'm just going to separate it a little bit. So for the area of the base, it is a square, and we already did area formulas. So the area of a square is side squared, which would give us 144. Next, I want to do the perimeter of the base, and the perimeter is going to be 12 times 4, because once again, it is a square, and to find the perimeter of a square, it's one side times 4, or you could do 12 plus 12 plus 12 plus 12. And either way, you're going to get 48. And now we can kind of go back and substitute it all into the whole equation. So I'm just going to kind of draw an arrow down here. And then total surface area, so we're going to kind of plug everything in. 1/2, our slant height is, remember, the height that is slanted. So that's actually this piece right here, so it's not perpendicular to the base. So that is going to be 15. And then we had our perimeter, which was 48. And then the area of the base, which was 144. And now when we simplify this whole thing out, we are going to get 504 feet squared. So 504 feet squared. And this is really the only surface area formula where you really do kind of want to break it apart by pieces, because like I said, it is going to make it a lot easier. The square pyramids aren't too bad, but if you get to like a rectangle or a triangle, that could really get confusing, which is why you want to find the base, the area of the base separately, and the perimeter of the base separately as well. All right, we got 2 more here. The next one, this one is the hemisphere. So you could tell that it is half of a sphere just by looking at it, because it's not a full sphere. And then this one, the surface area was 3 pi r squared. So 3 times pi, our radius is 5. We don't have to take half of the diameter because it gives us the radius. And then we just simplify that in the calculator. It is 235.6 inches squared. And then the very last one, this one is going to be our cone example. And the cone for your surface area, this one also has 2 separate components that is split up by a plus sign. So I'm going to do this one down here. So your surface area, the first half of your surface area is finding the area of the base, which the base is actually at the top. So pi r squared. And then our radius for this one is 5. And then the second half is pi times radius, which is 5 again, times your slant height. So with this one, your slant height, once again, is the height that is slanted. So it's not perpendicular to the base. So if we take a look, we have 2 heights here. We have 12 and we have 13. 12 is perpendicular to the base, so 12 is actually considered the height of the cone. So we're not going to use 12, we do need to use 13. Another way to kind of look at this is that the slant height is always going to be the hypotenuse of the right triangle. So that's another way to kind of look at it. Sometimes it's hard to kind of visualize that, but with this one you can kind of see that there is a right triangle in the picture. So the slant height is 13. Once again, I'm going to split it apart when I multiply them together. So the first half, pi r squared, you get 78.4. And then the second half, you get 204.2. Lastly, I'm going to add them together. So 282.6. And this one is centimeters squared. And one thing I guess I should have mentioned at the beginning is that since surface area is a type of area, it's like the sum of all of the areas of the solid, the units is still units squared. We're going to do volume next, and that's the one where it will be units cubed. But with surface area, like I said, it's all the areas, so it's still units squared. So that does bring us to the end of this section. Make sure to enter in the code word and just let me know if you have questions.